pressure more than likely is given in millimeter mercury, so you need to know the conversion there. Okay, 1 atm is equivalent to 760 millimeter mercury. So anything above 760 is a little bit more than 1 atm. Anything below 760 is a little bit less than 1 atm. Okay, so we're trying to give you, these are the different units that we can use, and this is probably something that you are all familiar with. PSI, pound per square inch. And you use that to gauge the tire pressure of your car. So 14.696 pound per square inch is equivalent to 1 atm. So the pressure in the tire of your car is roughly about, well, you're inflating it to 30 psi. So that's roughly about 2 atm inside the tire. Okay. So the conversion there, and again, we will give you the conversion table. If we give you a pressure in the unit, anything other than atm there, we will tell you the conversion factor there. You don't have to memorize it. Okay. And you just have to pay very close attention to the unit of the pressure there. Now, with the temperature and pressure introduced here, we want to use what we call an STP, a condition of STP. This is something that I need you to memorize. What is STP? Now, STP stands for standard temperature and standard pressure. Okay. Standard temperature would be either 0 degrees Celsius or 273.15 Kelvin. Pay attention to the units. Okay. Units are very important. So the standard temperature would be something around the freezing point of water. 0 degrees Celsius or 273.15. And you can see Fahrenheit is not being used here. Yeah. And the standard pressure is either 1 atm or 760 millimeter mercury. Now, in your homework assignment and in the upcoming exam, you may see a statement, under STP, certain amount of gas is occupying certain amount of volume. Now, the term STP, the capital letters together, stand, when you see STP, the temperature is given, the pressure is given. These are the quantities. So you need to memorize what is the standard temperature, what is the standard pressure there. Okay. Although you may need to use, for the temperature there, you may need to use Kelvin in your calculation. Make sure you do not plug in 0 in there. Instead, you plug in 273.15 in your equation when you do calculation. And the pressure, you may need to use atm. Now, if the question is given, if the quantity given is in millimeter mercury, you got to convert it into atm. The relationship is 1 atm equals to 760 millimeter mercury. Okay, so that's our conversion factor. So STP. Now we talked about the 4 physical quantities that we must identify when we try to describe the behavior of a certain amount of gas there, and that's the number of moles, the pressure, the temperature, and the volume. Okay. Volume is measured. We can measure volume with different devices there. Okay. Volume depends on the temperature for the gas. Volume depends on the temperature. Depends on the pressure. Okay. So these are the first 3 quantities, the 4 quantities that we want to introduce here. And so that's our first learning objective. And we summarize the general behavior of gases, their general properties of gases there. We make some assumptions about all gases there. We come up with the assumption of the ideal gas, and then we introduce the pressure, the volume, the temperature, and the number of moles of gas. And those are the 4 quantities we need to know when we study the behavior of gas. The next learning objective, we're going to get into the topic where how are these things related to one another? These 4 quantities, number of moles, pressure, and volume, and the temperature. How are they related to one another? We are going to introduce, in this particular learning objective, we're going to introduce individual gas laws. Okay, and therefore we call it Boyle's law, Charles' law, and Gay-Lussac's law, and Avogadro's law. Well, each individual gas law, when we study the gas behavior there, we have 4 quantities there. Okay? We don't want to have 4 variables changing all at the same time. So when we study gas behaviors, or the scientists who study gas behaviors at the beginning there, well, they try to hold, out of those 4 quantities, they try to hold 2 of the quantities constant and change. Manipulating one of the other, then how does that affect the 3rd quantity there? So that's what these individual gas laws are all about. And we're trying to investigate holding 2 of the 4 quantities constant. Remember that number of moles, volume, temperature, and pressure. Holding out of those 4 quantities there, we hold 2 of them constant, We studied the relationship between the other two. When you change one of the other two, how does that affect the last quantity there? So the pressure volume variation, temperature volume variation, pressure temperature volume variation. Okay, those are the individual gas laws that we will talk about. But eventually, in this particular chapter, there is only one equation you need to memorize. I try to tell you, chemistry is easy. So not a whole lot of things you have to memorize. There's only one equation you need to memorize. That's the ideal gas law equation, PV equals nRT. In that equation, you see pressure, you see volume, you see temperature, you see N is the number of moles. Okay. In that equation, you have 5 different quantities, all associated together with one equation there. And that is the central equation you need to remember. And using that single equation, you should be able to answer any type of questions involved here. So the relationship between pressure, volume, temperature, volume, pressure, temperature, number of moles to volume, and when you change the pressure and volume, number of moles or temperature, what happens to the other quantities there? And how do you determine the molar? This is something that we will do today in the laboratory. How do we determine molar mass of a compound or volatile liquid there? And the stoichiometry, if you have 2 gases reacting with one another, you have to make sure the basic stoichiometry still governs the chemical reaction, the balanced chemical reaction equation there. And we can also, since number of moles is related to pressure, temperature, and volume, under a particular pressure, volume, volume and temperature there, we can figure out how many moles of gases we have here. Once you have the number of moles there, molar ratio, so we can have stoichiometry calculations involving gases here. So that's going to be the focus of our second learning objective there. So studying different quantities, a relationship of 2 quantities that involves that are related to for the 4 quantities are related to the gas properties there, and some pioneers in scientific research have done a lot of work there. So this is something that Robert Boyle studied the behavior of gases there. So we call it Boyle's law. Boyle's law governs the relationship between the pressure and the volume. So what he found out on his research there is that the pressure of a system of gas particles is inversely proportional to the volume if you have a fixed quantity, fixed number of moles, and if you hold the temperature constant. So among those 4 physical quantities there, pressure, volume, temperature, and the number of moles, we hold 2 of them constant. That is, number of moles is constant, okay, temperature is constant. What's the relationship between pressure and volume? It only makes sense. Now you know the higher the pressure, the lower the volume. They're inversely proportional. So the mathematical equation representing Boyle's law is that P is inversely proportional to volume. Okay. If you have a system of gas under one condition, one particular pressure, they occupy a certain amount of volume. If you change the pressure, volume will also change. And so P1, V1 equals to P2. So that's the first individual gas law equation. Do we have to memorize this? Well, great. If you want to memorize this, that's fine. But eventually, if you remember that one central gas law equation, PV equals nRT, and you will know, and you will be able to figure out that P1, V1 equals to, P1, V1 equals to N times R times